Hi students, welcome to today's class. Today I am going to explain limit of a sum problems, okay, so which are very important for your JEE MAINS examination. Let us see the first problem. Limit n tends to infinity, sigma r runs from 1 to n 1 by root of 4n square minus r square. Okay, now so it's a very easy problem. This we call it as a by seeing this problem. So limit n tends to infinity, sigma, limit n tends to infinity, sigma will be there. So immediately you have to catch that this is a limit of a sum problem. Okay, now so let us see the solution. So very easy problem. This is a first write down as it is. Limit n tends to infinity, sigma r runs from 1 to n 1 by root over 4n square minus n square. No, you take n square common outside. So this is equal to n come here 4 minus r by n whole square. Okay, now so take this 1 by n outside. So this is equal to limit n tends to infinity 1 by n into sigma r runs from 1 to n 1 by root of 4 minus r by n whole square. This should be your format. So the first thing is limit n tends to infinity should be there. Limit n tends to infinity should be there. Here 1 by n should be there compulsory. Here sigma r runs from n or 0 runs from n minus 1, like that. Depending upon the problem, r value, see here 1 value, n value will change. Okay, now this function, whatever may be this function, this should be f of r by n. F of r by n. Okay, now so here r by n should be there. So this type of problem, maximum you will get that type of format you will get. Then how to solve this problem? So this is nothing but integral 0 to 1. So here 1 by root of 4 minus x square dx. Understand this? Okay, now so here 4 I will write down 0 to 1 by root of 2 square minus x square dx. Okay, so this is 1 by root of a square minus x square. So what is your answer? So this is equal to 1 by a, that is 1 by 2a, a sine inverse of x by 2. Okay, now sine inverse of x by 2. So only 1 by 2, not will be sine inverse of x by 2. So this is upper limit 1, lower limit 0. So sine inverse of x by 2, substitute first 1 by 2. Sine inverse of 1 by 2 means what? Sine 30, that is equal to pi by 6 minus 0, pi by 6 your answer. So for this problem, the answer should be pi by 6. Whatever may be, now I am going to explain a few problems in this. The first thing should be limit n tends to infinity. Next, immediately you have to get 1 by n. Next, immediately you have to get down sigma, right? So limit 1 by n sigma. Limit 1 by n sigma. So the same format should come. Here whatever may be the function, that should be f of r by n should come. Okay, now right. So let us see the next problem. Welcome to this problem. Evaluate limit n tends to infinity, sigma r runs from 1 to n 1 by root of n plus r by n minus r. Very easy problem. Here limit is there. So here limit is there. Yes, limit n tends to infinity, take 1 by n, you can take 1 by n, r runs from 1 to n. So here limit is there, 1 by n is there, sigma is there. All the three should be side by side. So that you can write it as 1 plus r by n by 1 minus r by n. Okay, can I write it as? So that means dividing both the terms with n. Okay, so now everything is clear. So this is a limit n tends to infinity is there, 1 by n is there, sigma r runs from 1 to n is there. This is a function in the terms of, this is a function in terms of r by n. Okay, now so in place of r by n we write down x. So this is nothing but 0 to n root of 1 plus x by 1 minus x dx. Understand? Okay. Now what I am going to do in this class is there, no, I am explaining this some few problems there, how to convert this in this format. Afterwards I will take up this problem. Okay, now how to solve it I will explain. Here different methods are there. So this comes under substitution method. Here we will put cos 2 theta. Here we will put cos 2 theta. So 1 plus cos theta by 1 minus cos 2 theta. Again cos 2 theta is equal to x. We will differentiate and limits also will change. Okay, now I will explain the solution later. Now, how to convert the given limit of a sum problem into this format, I am going to explain. Okay, now I hope that you understand this concept. Let us go for next problem. Welcome to the next problem. So, here you see here limit n tends to n 1 by n square sigma r runs from 1 to n r into e to the power of r by n. See here in our format is limit n tends to infinity is there. Here only 1 by n should be there, but here 1 by n square is there. That is why what you will do, take 1n to inside. So, this is equal to limit n tends to infinity 1 by n sigma r runs from 1 to n r by n into e to the power of r by n. So, this is a function of r by n. Understand this? Now, this problem will become, how the problem will become? So, this is a limit 0 to 1. So, this is r by n, this is a x e power x dx. This is by parts formula, I will explain later. Okay, now. So, here 1 by x, our format is limit 1 by n sigma. Limit 1 by n sigma should be there. Of course, limit n tends to infinity, r runs from 1 to n, that limits value will be changed from problem to problem. So, wherever r by n is there, substitute x. Wherever r by n is there, substitute x. I will explain this solution, different methods are there. This comes under by parts formula. Okay, now. So, I hope that you understand this solution. Let us go for next problem. Welcome to this problem. So, here evaluate limit n tends to infinity 1 by n plus 1 by n plus 1 plus 1 by n plus 2 so on 1 by 3 plus n. So, this sum also can be done using limit of a sum problem. Okay, now then how to do? So, here there is no sigma notation is there, 1 by n is not there. So, we have to create, we should get an idea that this is a problem belongs to limit of a sum problem definite integration. Okay, now right. But in the examination it won't be given any this is problem from definite integration like that, he won't mention the chapter name. That meant we have to get an idea. Then how to, this is a sum of n terms, sum of some n terms or 2n terms, we have to write it in a sigma notation. Let us see how you to write down. So, this is equal to limit n tends to infinity. See here, observe here n plus 1, n plus 2, n plus 3. So, what the last term should be? N plus 2n. 3n is there, last nth term, that is a 3n is there denominator. That must be how much? See here, n plus 1, n plus 2, n plus 3, n plus 1, so on. How much should be there? N plus 2n. Numerator is same, 1, 1, 1, 1. So, now I am writing in the sigma notation, sigma. Okay, first numerator is 1, 1, 1, right? 1 I wrote 1 by denominator. See here, n plus 1, n plus 2. For everywhere n is common, that's why n plus what is changing? So, here 1, 2, 3, 4, that is a variable. In that place write down r. Understand this? Right. Now, your r runs from 0 to, that means why? Because here n plus 0, first term is how much? From 0 to last term is how much? 2n. So, this is your sigma notation. So, if you expand this sigma, you will get this term only. Sigma means summation. Put r is equal to 0, n plus 0, n. Next 1, n plus 1, next n plus 2, denominator. Last term 2n, n plus 2n you will get. Understand this? Now, for our format, what should we get here? We have to get here 1 by n should be there, no? That's why take n common outside. Limit n tends to infinity 1 by n sigma r runs from 0 to 2n 1 by 1 plus r by n. Understand? So, limit n tends to infinity is there, 1 by n is there, sigma is there, 1 plus r by n. Wherever r by n is there, put x. So, this this problem will become 0 to, see here 2n. What are the n coefficient? 2. That is why 0 to 2, 1 by 1 plus x dx. Understand this? Of course, I will explain. So, the integral of 1 by 1 plus x is equal to log of 1 plus x. I will explain afterwards. Understand this? So, this is the format. Here, sigma notation is not there. We wrote it sigma notation. Observe here, r runs from 0 to 2n. N coefficient is 2. That's why 0 to 2. Your limits are 0 to 2. Then I will explain afterwards how to solve this problem. Okay, now I hope that you understand the solution. Let us go for next problem. Welcome to this problem. Evaluate limit n tends to infinity n plus 1 upon n square plus 1 square plus n plus 2 upon n square plus 2 square plus so on. The last term is n plus n by n square plus n square. Now here whenever it is this problem is given, first of all, what are the fixed values? Is there any pattern is there? Yes, it is a pattern. See here, n square, observe the first terms, n square. Here also n square, okay. Second one, if it is 1 and the denominator 1 square is there. Here it is 2, denominator 2 square is there. If it is 3, 3 square is there. Last one, n, denominator n square is there. So let us observe that pattern. Then how to convert this into our limit of a sum problem. Okay, so let us see here. So limit n tends to infinity. I am going to write it in the sigma notation. First you write down the fixed terms. What are the fixed terms? Here n is there, denominator n square is there for every term, n square plus, if it is first term, if 1 is there, denominator 1 square, second term 2 square, last term n square. That's why here r plus r square, where r runs from 1 to n. See here, then it will be okay. N plus r by n square plus r square, r runs from 1 to n. Now each term will come. Understand, if you substitute r is equal to 1, 2, 3, last term, if you substitute n here, n plus n by n square plus n square. Okay, now after this, the problem will be very easy. So sigma r runs from 1 to n. So limit n tends to infinity is there, sigma is there. Here how much you have to get? 1 by n you have to get. Okay, now then how you will get? So take the n common outside, 1 plus r by n. Here you take n square common outside, 1 plus r square by n square. Okay, n by n square will get cancelled. So this is equal to limit n tends to infinity 1 by n, sigma r runs from 1 by n. This is 1 plus r by n by 1 plus r square by n square. Okay, now so everything format is there. Now main this important, these three terms are very, very important. Here it should be a function of r by n. Wherever r by n is there, put x. So your problem is, this is nothing but, your problem is integral 0 to 1 plus x by 1 plus x square dx. So this problem is 1 plus x by 1 plus x square dx. This can be done by dividing 1 plus x with 1 plus x square like that. Otherwise, by taking partial fractions like that we can do. Okay, now so I hope that you understand this solution. Let us go for next problem. Welcome to this problem. So this is one of the variety problem. Limit n tends to infinity. See here, 1 power m plus 2 power m plus 3 power m, so on n power m upon n power m plus 1. Then how to do this problem? Right. I will do like this, limit n tends to infinity. Here n to the power of m plus 1 is there. That means a to the power of m plus n. That is for a power m into a power n. A power m into a power n. That means n power n. 1 n you can take common outside. So this is 1, 2 power m, 3 power m plus so on n power m by n power m. Okay, that means here this can be written as n power m into n power 1. That n I have taken outside. Why? Because we required 1 by n. Right. Next step is limit n tends to infinity. We want required. So this is here n power m I will distribute to each and every term. Here 1, 2, 3. So 1 power m by n power m. So this is equal to 1 by 2 whole power m. 2 power n by n power m. This is a 2 by n whole power m. So if you so on, this is a n by n whole power m, right? I can write it in a sigma notation. So this is equal to limit n tends to infinity 1 by n sigma. See here, for all the terms power is m. For all the terms power is m. See the numerators 1, 2, 3. Numerators are variables. Denominators you see here. So this is a n here. So denominators n. That means this is nothing but r by n whole power m. where r runs from 1 to n. See here, r runs from 1, 2, 3, so on n. Denominator is n, power is m. Okay, now, so this can, everything is okay. So we have limit n tends to infinity, 1 by n, sigma notation. All the three together have to come. So this is nothing but integral 0 to 1 x power m dx. Wherever r by n is there, you have to put x. So this problem is very easy. X power m plus 1 by m plus 1, upper limit, lower limit. So upper limit is 1, substitute 1 by m plus 1. So 1 by m plus 1 will be your answer, final answer. Okay, now, right. So very, very nice problem this is. I hope that you understand this solution. Let us go for next problem. Dear students, so this is one of the very interesting problem. So limit n tends to infinity, 1 to the power of 4 upon 1 to the power of 5 plus 2 to the power of 5 plus 2 to the power of 4 upon 2 to the power of 5 plus n to the power of 5 plus so on. The last term is n power 4 by n to the power of 5 plus n to the power of 5. So first of all, I want to write this expression in sigma notation. Observe the pattern. Observe the numerator, 1 power 4, 2 power 4, 3 power 4, n power 4. So here variables are coming 1, 1, 1, 1, 2, 1, 2, 3, 4. Power is 4. Denominator you observe here, 1 power 5, 2 power 5, n power 5. So here second term is n power 5, n power 5, n power 5, it is constant. And one more thing what you have to observe is 1 power 4 denominator 1 power 5, 2 power 4 denominator 2 power 5. Like that last term n power 4 denominator n power 5. So observe that. So now I am going to write it in the sigma notation like this. Limit n tends to infinity sigma. So wherever these variables are there, changing terms, I will put it r. So this is r to the power of 4 by r to the power of 5 plus n to the power of 5 is fixed here, n power 5, n power 5, n power 5. Now your r runs from 1 to n. Check it, such a big expression. I wrote it in a simple sigma notation. If you put r is equal to 1, 1 to the power of 4 by 1 to the power of 5 plus n to the power of 5. If you put r is equal to 2, 2 to the power of 4 by 2 to the power of 5 plus n to the power. Of course, sigma means summation. Okay, next. We have limit n tends to infinity. We have in between these two, 1 by n should come. Then how to come? Right, we will do like this. Limit n tends to infinity, sigma r runs from 1 to n. So this is r power 4 by r power 5 plus n power 5. No, can I take n to the power of 5 common outside? Yes, if I take n to the power of 5 common outside. So this is equal to r to the power of 5 by n to the power of 5 plus 1. Okay, now, right. Here denominator n to the power of 5 is there. We want 1n outside. Why? Because 1 by n. In between these two, 1 by n should be there. So out of n to the power of 5, out of 5 n's, take 1 by denominator. I am talking. Take 1 by n, 1n outside. Why? Because we required it. Another 4 no, put it in the denominator of r to the power of 4. Now, so this is equal to limit n tends to infinity. Okay. 1 by n, we want between these two, between limit and sigma, there is a small term 1 by n. R runs from 1 to n. So this is equal to r by n whole power 4 by r by n whole power 5 plus 1. So everything is clear. So we have limit n tends to infinity, we have 1 by n, we have sigma 1, 2, 3. Then it is a function of r by n. So wherever r by n is there, put x. So this is up to here, this is nothing but sigma 0 to 1, n coefficient 1. So this is a x power 4 by x power 5 plus 1 dx. Understand? So I will tell how to solve it, this problem. So put x to the power of 5 is equal to t. Therefore 5 into x to the power of 4 dx is equal to dt. X to the power of 4 dx is equal to 1 by 5 dt. Afterwards 1 by t log of 1 plus t. I will explain this method how to solve it. The first my concentration is this in this class, how to convert given limit of a sum problem into a definite integration. That is my focus on today's class. Okay, now let us see the next problem. Welcome to this problem. So, evaluate n tends to infinity 1 by n square into secant square 1 by n square plus 2 by n square into secant square 4 by n square plus so on 1 by n square. So, sorry, here it should be 1 by n square, 1 by n square into secant square 1 by, because here 1 by n square, 2 by n square, 1 by n square, secant square 1. Then how to evaluate this limit? So, if the same problem is given in your examination, just he will question, then the value of limit is options A, B, C, D will be there. So, immediately you have to get an idea that the expression, whatever may be this expression, you have to write it in a sigma notation. Then how to write it as sigma notation, right? So, first limit n tends to infinity. What are the changing terms? First, not changing term, that means constant. Constant, we should not say constant. What are fixed terms? 1 by n square. See here, n square, n square, n square, n square, n square. Here secant square 1 is there, no? Secant square 1 is also, I can write down n square by n square. That 1 square is there, no? In place of 1 square, 1 is there, no? In place of n square by n square, I can write down. Why? Because see here, n square, n square. That's why here also should be n square. Okay. So, outside n square, inside n square. That means I can write it like this. Sigma 1 by n square, secant square, here also n square. I fix it. Here only the change. If it is 1 is there, 1. If it 2 is there, 4 is coming. If it is 2 is there, 4 is coming. If it is okay. Here n is not there. So, here it should be n by n square. Right. So, 1 by n is right only. So, here 1 by n is the last term. Can I write down n by n square? Right. So, if it is n, it is n square is there. Okay. So, then how to write down? So, here if it is r, here r square should be there. Therefore, r runs from 1 to n. R runs from 1 to n. Now, check it. First put 1 here, 1 by n square secant square, 1 by n square, put n is equal to r is equal to 2, r by 2 by n square secant square, 4 by n square. Last term n by n square, ante 1 by n, secant square, n square by n square. Understand this? Right. Now, this is but we want in between these two, we want 1 by n we want. So, here r by n square is there, no? Take 1 by 1n outside, okay? So, this is a limit n tends to infinity 1 by n, sigma r runs from 1 by n, r runs from 1 to n, r by n secant square, r by n whole square. So, here everything clear. So, limit n tends to infinity is there, 1 by n is there, sigma r runs from 1 to n is there. So, it is a function of f of r by n. So, this is can be converted into definite integral as 0 to 1. Wherever x there, you put x secant square dx. Okay, now. So, this can be easily done by substituting x square is equal to t. So, x square is equal to t means 2x. There is 1 by 2. Secant square means integral of secant square is tan x. Easily we can do. Okay, now. So, very nice problem this is. Easily we can convert this into definite integration. Okay. So, let us see the next problem. Welcome back to this problem. So, this is one of the very nice interesting problem. Limit n tends to infinity n factorial whole to the power of 1 by n upon n. Then how to do this problem? So, let this be L. This problem is limit n tends to infinity n factorial whole power n by n. Then how to do this problem? So, let us expand this. What happens is here. First of all, here whole power 1 by n is there. No, the position of that 1 power n is not in the power. It should come down. It should be between the limit and sigma. Limit and sigma, it should be safely placed in 1 by n, but it is in the power. So, how the power will come as a coefficient? So, then by applying the logarithms on both sides. So, let us apply the logarithms on both sides. Log L to the base e is equal to limit n tends to infinity. So, if we apply logarithms on both sides, Okay. So before applying this, so let us do one thing. Why? Because here whole power 1 by n is there. No. This is for only n factorial, but for n it is not there. That's why make it for n also whole power 1 by n. So I will do like this. Limit n tends to infinity, n factorial by n power n whole power 1 by n. Can I write it as? So that n will get cancelled, your n remains same. Then you can apply this 1 by n come in the coefficient. So that is equal to 1 by n into log of n factorial by n power n. Okay now. So this is equal to limit n tends to infinity 1 by n into log of, what is n factorial? As we know that n factorial is 1 into 2 into 3 into so on n upon n power n. How many n's are there? How many n's are there? N's are there. Multiplication. n into so on n. Okay now? Right. So this as you write down 1 by n into 2 by n into 3 by n into so on n by n. Okay now? Right. Now I will write down another step. Limit n tends to infinity 1 by n into, this is what? Log a into b into c into d means what? Log a plus log b plus log c. That means log of 1 by n plus log of 2 by n plus so on log of n by n. Understand this? Okay, right. So now we can write down sigma notation. Limit n tends to infinity 1 by n sigma. So here logarithm is there compulsory. Denominator n. Denominator n is there. Only the power, so numerators 1, 2, 3, so on, they are the variables. That's why put r. So here r runs from 1 to n. So here everything is clear. So here limit n tends to infinity is there. Your 1 by n is there. Your sigma notation is there. That is a function of r by n. So this can be written as integral 0 to 1 log x dx. So integral 0 to 1 log x dx, we have the formula, we will apply. But remember that this is not L, this is log L to the base e. For example, whatever may be the value you got, for example, if you got the value k, got the value k, so your L value is e power k, that is your final answer. Understand? I will explain how to find out the integral of log x. So we have to put it as a 1. Take log x outside, by parts formula we will do. Okay. If the answer is k, so your b, remember that this is log L value, not L value. So to get L value, we know the how to convert logarithmic function into exponential function, that will be e power k. Okay na? So this problem comes under e power k answer. Okay na? Right. So let us see the next problem. Welcome to this problem. So here it is given if Sn, this is a one expression, 1 by 1 plus root n plus 1 by 2 plus root n plus so on 1 by n plus root of n square, then limit n tends to infinity, Sn value is how much? Okay now, right, we will do like this. Limit n tends to infinity, Sn means total function, total sum expression, 1 by 1 plus root n, 1 by 2 plus root of 2n plus so on 1 by root of n plus root of n square means n into n. Why I wrote means see here 1 plus root n, 2 plus root of 2n second term, third term 1 by 3 plus root of 3n, nth term is n plus root of n into n. Okay now, right. Then how to change this expression into sigma notation? Very easy. So this is a limit n tends to infinity sigma. So what are the constant? Here 1 is constant. Here root n is there. Outside 1, 1n, 2, 2n, 3, 3n. That means if it is r plus root of rn. So r runs from 1 to n. That's all. Numerator is fixed. Denominator 1, 2, 3, so on n. If it is 1, 1n. If it is 2, 2n. If it is n, nn. Therefore, it is r, Rn over now. Between these two, what you have to get? 1 by n you have to get. Where it will come? It will have to come from this only. So otherwise you cannot put, okay, put R. Let us take it as limit n tends to infinity, R runs from 1 to n, 1 by. Can I take n common outside? Say if you take common outside, what happens? R by n, root of R by n. Can I write it as nothing wrong? Check it. N cancel. Root of here, root of n square. N will get cancelled, R into n, right? Take 1 by n outside. So this is equal to limit n tends to infinity, 1 by n, sigma R runs from 1 to n. This is a 1 by R by n plus root of R by n. Okay now? So everything is there. So limit is there, 1 by n is there, sigma is there. Father, mother, son. Father, limit n tends to infinity. Mother, sigma R runs from n. Your children is 1 by n. That should be the family. That should be the family. For every problem, this should be the family. Mother, father, son. Okay, right. Last R by n should be there. R by n will be there. So this can be written as integral 0 to 1 by x plus root x dx. Understand this? Integral 0 to 1 by x plus root x. I will explain afterwards how to solve this. Okay. So dear students, in this video what I explained is, given a limit of a sum problem, how to convert it into definite integration. How to convert into a problem of definite integration. Okay. So I hope that you enjoyed today's class. With some more problems tomorrow I will come to you. So until then, all the best.